Hi everyone, welcome back to this channel. This is something that I want to share with you after finding out FieldFox has an IF output. So it has been a long while since I wanted to try this, but because of other projects being called into, so right now I have some buffer to try out and I will just want to record it down and share with you. So let's look at the setup, how it looks like physically. So this is how the connections looks like, the physical connections. So we have this IF output from the FieldFox. So this is a receiver, the first stage of the receiver, where you have the antenna connected to the input of the spectrum analyzer, and this is the IF output, and it's a SMB connector, and this output will connect to the input of another FieldFox as a spectrum analyzer mode also. So physically, this is the receiver and it converts to IF, and this is to measure the IF output. I'm using one FieldFox as the receiver and connect the IF output of this FieldFox to another FieldFox as a spectrum analyzer mode also, and to measure the baseband, the IF, sorry, it's not baseband, to measure the IF output of the first FieldFox. And this is how the LTE signal looks like over here right now at 763 10 MHz bandwidth, and that signal should fall within that spectrum, and this is the IF. So as we know that super heterodyne circuit, when we change the LO or the RF, the IF always maintain the same range that we want it to be, meaning that if I change the frequency right now, so the frequency of this receiver, without changing anything over here, I should see the signal being moved about. So you can't really see the whole signal chunk because of the second channel is a bit wider than 10 meg, and I believe this FieldFox I'm using right now has a limitation of 10 meg IF bandwidth. So I can show you that if I change the frequency span to 20 meg, it still stays about 10 meg-ish. I can make it bigger. So its sweep and scan is always going through that 29 meg center frequency. If you really want to look at how it looks like, we should change that to RTSA mode, and then you can really see what I'm talking about. So in FieldFox, in spectrum analyzer mode, you can utilize IF bandwidth if you have the options. And if I change that to real-time backend, after initializing, you should see that same thing coming out from here. So I found that at spectrum analyzer mode, the center frequency is about 29.3, but in RTSA mode, the IF center frequency should be about 33. So it's about there. Yeah, 33.8-ish. So this is the LTE signal again. So it converts to IF bandwidth. I can change that. So this is where you're going to see the big difference. If I change that to 20 meg, it will just flat out because it could be the limitation of that IF bandwidth output. I still have to check that online and see whether I can find that. So in any case, this is how it looks like, 10 meg, and the output is just 10 meg, nicely done here. So the next thing I want to show you is if I change the center frequency, you see that the signal will stay within this band. So let's see, we check the other frequency range, another channel. So this is about this 10 meg, no, it's more than that, so you can't really lock on that. So you see that there's another 10 meg here, which I can utilize 875 meg, and it just shows here. So to me, this is very useful when you need to scan through a band, a certain band of signal, when you have to change the center frequency, but you want the setup to always maintain at the same setting. So this is how you can utilize the IF bandwidth. This is just one of the thoughts I have. I personally haven't used this before, but this, I think we can utilize this in the future for some interference checking. So the next mode that we can utilize this IF output is what we call the IQ analyzer. So IQ analyzer is very similar to real-time if you set more than 10 meg, it will just flat out. Unfortunately, this FieldFox doesn't offer more than 10 meg for this IQ analyzer, but you get the gist. In summary, yes, the IF bandwidth can be used for interference measurements. If you want to maintain and stay at the same range at different frequency band, you can actually utilize that. So two questions pop up. One of it, can we use LTSA to measure that? Because we should see a quicker signal in that sense. Let's change that to center frequency 33.8. So we have that, so we set it to 763. Same thing, and then we change the center frequency, so you can see that it does carry on what's being received and down convert to IF bandwidth. The other things I want to try is if we set this to, yep, it's cut off by the bandwidth limitations. But it seems like if my receiver span is lower than the bandwidth, I'm still able to do an IF out of 10 meg. Okay, that's a new finding. Okay, it seems like IF output is useful only in zero span. Alright, I never know that. Let's try that out. And as you can see, the narrow span is about 5 megahertz. So the output is about 25 megahertz bandwidth, center at 33.75. That's what we're having right now. Let's look at it right now. That's interesting. Let's change to spec N, and let's do a center 763. Yeah, 763 megahertz. And okay, yeah, somewhere there. And let's change to zero span, and I can change my center frequency back to that. Oh, it's looking at the whole 33.8 meg, but one thing I want to change is this one, not that. Output use, no, I can't change to that. That's interesting, I can't change that. Let's go to real time, and bandwidth, path, auto, let's change to 10 meg. Okay, looks like it's working. 100 meg, no, it's not working. So 10 meg output. Let's go back to spec N, zero span, sweep time, let's make it to something faster. Then bandwidth, let's increase it. Nothing changed over here. Advanced, nope. Oversweep, nope. Step, nothing. Okay, so it seems like it's not working in that way. So this is the sweep time, zero span measurements, and they say at least one sweep must be made in order to tune the FieldFox advanced output. One sweep, so it says one sweep. So let's say we do a trigger, single, and then we go back to advanced. No. Anyway, so this is what I came for. I managed to get the signal out at 33.8 as shown as here, 33.875. So 33.75 meg center frequency, so we can change the narrow. So by default it's 25 meg, which I don't think so. Let's increase that. Oh, we can't, because this FieldFox is limited to 10 meg. And let's go back here. Spectrum analyzer, spectrum, and 25. Is there anything on 25? Let's do this. Sweep. Continue on. Let's do frequency span. Frequency span. I can do it bigger, but it's just sweep. Yeah, just sweeping through and then just accumulate over here. Anyway, hope you pick up something from here. So in summary, again, you can utilize the IF output of the first receiver and you measure at the second spectrum analyzer, not necessarily a FieldFox. It's just that I only have this spectrum analyzer with me right now. Thanks for your time. Thanks for watching.